Hands-on software. Okay, so I will open now the software. This is the time now. So I will stop sharing. Okay, very good. I have the question there. Let me check. Sure. Okay, anybody want to ask first? We already have MNOVA, but license already expired. You can share the license. Okay, I will see you personally. Okay, Solihin. Is it okay, Solihin? I will see you personally because this is kind of actually I cannot share, but it's okay for the learning purpose. I can share. So I will open the tool. So this is the NMR. First, they will come up with this. Oh no, you cannot see. I should share. I press. You can see my screen first screen. So double click here. So they will code the meter license. So you have to remember this one. Okay, you have to aware about this one. So the license valid until 4th May 2034. And it will come out with this pop-up with this icon. Can minimize this one. Okay, we will explore this one seriously after this. So okay, I have a few examples for the NMR. So it's okay, we try to explore one by one. So this is the windows that the NMR spectra will be pop up. Okay, this is the folder that we will use. Okay. Okay. You can also put your folder, your all the NMR software to C. Go to broker. Okay, open this PC. You will see C broker Topspin 3.5. Okay, exam data. Okay, you have two technique. First, you put all the NMR software, NMR spectra. For example, I copy this one, copy, and I paste this one. Paste. Okay, and they are not shown here. You have to. You see, they have here NMR, and easily for you just drag. Or you can put anywhere your NMR software, and suddenly just drag. I will show you later. Let me explain all about the bar here. Start. Don't use. Don't don't use this tab. Okay, because usually for this tab is used for the operators. Okay, start, submit, experiment, something like that. Okay. So process, we use only process, analyze, publish. View, not really. We don't use too much. Okay. Process, analyze, publish. That's all. Okay. For the process, this is how we process. We pick, we do integrations. We are doing pick. Okay, every spectrum band, something like that. Every spectrum pick, we want to know the value, so we are using picks. For the integrates, we want to know, especially for the protons NMR, how many proton in that particular picks. We will show you after this. Okay. So for the calibrate, if if the reading, especially for reference CDCI3, is not correct, for example 7.20, so you want to change to 7.26, so you have to use calibrate. Adjust phase if the NMR phase is not really good. It's like high wire, the baseline is not really good, so you have to do it manually by using adjust phase. We will use, I will show you one by one about this one, okay? So the process spectrum, we don't use too much about this one. Okay, remember, process for processing. Analysis, usually we are not using this one because these applications for multiplet, something like that, is for the paid version of NMR. Okay, and also version for operators. Okay, so we use process on and publish only. Okay, for the publish, okay, this is where you can use. So the first one you can print. Okay, the second one you can save the current view of NMR as PNG, as picture in your for your thesis or supplementary informations. Okay. For the time being, you can chat or put WhatsApp. We try to read and try to answer your questions. Okay. So for this one, you can also call the NMR for spectra from here. Okay. This is one for the beginner. So locate the NMR. For example, this one I have my NMR in NMR for spec. No. No, oh no, this is, for example, I have to remember where I put the NMR. NMR for spec, okay. This one. Okay, you have to do it manually. And 1, 2, 3, 4, 5. If you don't remember one is what experiment, you can change it easily. Don't worry. Okay. So this one is for print, and this one is a new data set, something like that. Okay. So the rest that I want to show, we show you after this. Okay. You have three steps how to call your spectra. The first one you have to do from here, this icon. Okay, as I showed you before. The second one, you can put directly the spectrum in where is the locations. C, broker, topspin, blah, 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 exam data. It should be in exam data, okay? So, for example, like this. Okay, ZG30 is a proton, cozy, HSQC, HMBC, noisy, depth. I do it depth 135, 19, and 45. Okay, during the time, because the structure is quite complicated in the beginning. Okay, so I try to run all the experiments and at least we can know the spectra. Okay, so or you can do like this. Data. And choose all experiment you want. For beginning, we are using proton. This is the proton NMR. Okay. This is not good proton NMR. I tell you why. Okay. So, okay, you know, first you already know how to call the spectra. Okay. Okay. Okay, so for examples, how we can process this one. Okay, first thing that you have to do is find the reference peak for solvent. Okay, refer back the table that I will give you after this. Okay, for example, I guess, and I'm very confident this is the carbon. This is the solvent peak. Okay, so go to process. Calibrate axis if the solvent peak is not correct. Okay, so put it here. If you're not really confident, going back, increase, expand, should be this one, 7.26. So calibrate axis. This is already 7.26. This is the first one that you have to do. Because recently, when I tried to write a paper with my colleague, my supervisor in France, he complained about this one. And also I trust student very much, and I don't assume that that particular student not calibrate the NMR peak. Okay, you have to calibrate first. Okay, click OK, and they already have the correct orientations. So if okay, you can playing around. For example, like this, you have shrink it all the spectra. Okay, you can see all the peaks here. Okay, so this one is undo like this. Okay, only one undo they can do. Okay, so this one is again shrink, expand. Okay, you can do also expand like this if you want, but make sure your cursor is below the number. Okay. Okay, you can do this. Try to playing around with your own NMR. Okay. So this one, you can use this one to going up, going down. Okay, if this one is too messy, you cannot see anything, you can do like this and okay. If there are two, increase the intensity, so you just scroll the mouse. Okay, so I scroll the mouse. If they are too small, especially Shira's spectra for quinazolone, so you have to increase. Okay. If the in nature product, if you have impurities and you want to hide it, don't put too much. Just as long you can see the peaks. Okay, this is kind of tricks. Okay, for example, let me see. Let me see an example like this. I try to process. Okay. This is for me is pure compounds, but if you try to report like this is acceptable. We can see, oh, this is the pure compound. It's nice, and you can read the NMR. If you try to publish your works like this, or this is no, we can see the impurities here. The panel will say like that. Okay, so you cannot you cannot use a pin something like that to it's for me it's unethical, but I didn't know what you have done. Okay, so another example like we have for carbon actually. This one for carbons. So to make you safe, it's better to prepare like this. Okay. Okay. Okay, for the protons. Okay, next what we can do, you can add a grade. Okay, so you can see the ruler there, the grade. Okay, size of grade. You want to clean. You want to increase a big grade line. So or you want to add more. There's only three types. Okay, free grade from grade, and with a huge box, with a small box. Okay. And this one, if I said sometimes for the seniors student actually working with me with all, if I said overlay, so it's mean you have to use this one. Okay, okay, you can see this one, and after that I said overlay. So you try to put two NMR spectra with the same pass program in one pages, so you can see the difference. Okay? This is only working and very helpful anybody who are doing NMR. because NMR will sharing the same skeletons, only the different substitutions. Okay, or anybody who are working on synthesis, you want to compare with the proton for the starting material and the proton with your product, and you want to check whether the reaction is working or not. Normally, starting material, crude reactions. So you want to measure which peak is exist and which peak is new peak is formed. So these apps will help you a lot. Okay, for this one, if you try to do stacking, make sure the reference peak is similar. So you can see which peak is disappear, which peak is exist. Okay, make sure it is similar. Okay, so okay, this is different compounds. So from this multiple display options, they have a lot. Okay, so first you can separate into two spectra, or you can combine into one spectra. So if you want to combine, like this. Okay, if you want to separate, like this. You can put as much as you can, but the problem if you put much, the size of spectra will be smaller and you cannot see the difference. Okay, so R is reset individual scaling. Okay, that is okay. So so if you cannot use scroll like this, okay, you can use this one 2 times. If you want to reduce, you doesn't want to use this one, you can divide by 2 times. Okay, so this one you can adjust. Okay, and this one you can go adjust the positions, and this one you can okay. And if you want to adjust only one spectra, go to this button, choose whatever is it, whatever spectra you want, and it differentiate by color. So you can go in, okay, and stack with another one, okay. So if you want to okay, so if you click this box, it's only affect only one spectra. You can use this one, okay, and you can only use this one, discussion, or you want to move. You want to move only one spectra, you can click the box and you can move. Okay. Okay. And you can delete manually with selected NMR selected spectra, or you can return without save. Okay, this is for proton. This is for me, this is the best NMR spectra, the example that I can give it to you, because the first thing is the baseline. The baseline is smooth, it's okay. Like this morning, I see iron spectra. The baseline is not really good, so I'm not sure is related with the samples or related with quantity of samples. Please check again. So when you try to run the NMR, so you have to remember the peaks which is not represent the compounds. For example, for this separation process, I'm using hexane and also ethyl acetate. So there is still remaining ethyl acetate. Okay, so this is peak ethyl acetate 1, 2, 3. That's why I ask students to rotavec as efficient as you can. Okay, when your sample is already dry in round bottle flask, you can put DCM or chloroform to remove the remaining solvent, because NMR is very sensitive. Even 1 milligram, they can detect the existing of the phrase or impurity, something like that. Okay, this is for proton. Okay, we will do for adjust phase. Okay, how to do adjust phase? Okay, If the baseline for the proton and carbon is not okay, this is only 1D, used in 1D rules, okay, 1D experiment rules. If the carbon, depth, and also proton is not okay, you can use adjust phase. Okay, go only for 0 and 1. Okay, click 0, it will adjust. See, adjust until you get a very good and smooth baseline. 0 also. Okay, and this one we will use for the carbon. And okay, don't save. This is my master file. Okay, if you satisfy and you want to save, please proceed with save. But because this one is my master file, I don't save. Okay. And again, for adjust phase done. So we go to calibrate assist done. Peak picking. Peak picking, they will come up with this one. You can do manual picking. This is auto picking. When you try to do adjustment or calibrations, the reading is already not accurate. Okay, so you have to do again. Okay, so if for example this one is already done the calibrations of solvent peaks, so suddenly it's the reading is run away. So I just delete everything. This is delete. So I just doing manual. Just choose the peak. Okay, this one. Okay, and this one. Okay, you can do manual picking. You're not really familiar with manual picking, it's better to use this one. Yeah? So you can use define manual pick. Okay, so define manual pick is tricky. So yeah. Okay, you can pick by regions. Pick by region. Yeah, okay. So you have to manual by region, delete by regions, add by regions, for and so on. This is very important. So, for example, for this one, I prefer to use this one and manually. And I know this is not the compound peak, so this is I just ignore. Just doing like this. This one is solvent. I don't want, so I just unclick. Okay, they are not highlighted. It means the option is not active. So I just expand. I don't want this one is because this one is ethylacetate. So I just clicking again. This is broad triplet. Okay. This is multiplet. This is doublet. Okay. So again, and I don't want this one because it's a solvent peak. So okay. Okay, if you want to print, make sure you print from here until here only. Okay, for the spectra NMR. Okay, don't do like this. No, it's not like that. Okay, because we want to expand more the NMR spectra. It's better to use like this. Clear, everybody can understand. And you can put, you can enlarge this part and put here and draw the structure here. And you can enlarge this part, put on the top. This is kind of how you can adjust and write your data. And this is very important. Okay, we already touched about the peaks. Okay, and I don't want to save it because this is my master file. Okay, so the next one we will go to integrate. This is very important. It will give you an ID how many proton in that particular peak. Okay, for example, I know this compound is for example, I don't know this compound, but I know this peak is a benzene ring, for example. So I can expand this one, for example, benzene ring, and I can do adjustment. Okay, this is not in the range of the in the range of the peak. So I can cut here, cut from here until here only. If you remember, when you are in undergraduates, you have to measure the height of NMR integrate, and after that divide with the smaller integrate, and you can get the all protons. This is the idea. But if you are doing higher postgraduate studies, the system will do it for you. Okay, so for example, this one is a okay. I just trim the spectrum. Okay, the peak that I don't want to include this. Go here, right click, delete current integral. Go here. Okay, and this one. Okay, done. You can do it. Okay, do it slowly. Okay, this is the. And after that, for example, if you want to inactive this one, put the calibrate. Okay, so this one I know this peak is doublet. Normally in benzene ring there are only one proton, so I just right click, calibrate current integral, put 1, see the number here, and this is for 0.85, 0.82, and they will change, the value will change. So this is 1, 0.9 represent 1 proton. This one 1.069 is 1 proton. This is 2 proton. This is 2 proton. Okay, and the rest will be changed also. Okay, okay, this is just the proton. Okay, I don't want to save it because this is the master. Oh, this is a master file. Okay, this is only for proton. Any question right now? Ada siapa nak tanya? Let me check the chat box. Where is the chat? No questions? Yeah, I think it's okay. So, okay, let's go to the carbon first. Okay, it's 11:21. Track again. Okay, so it's okay. I'm using the data is here. Okay, you can browse from here. You can call back your spectra for the 50 last data. Okay, so I prefer to go to browse here, for example. But during my study, I prefer to put there because it's easily to take everything. Okay, so we have data ZGPG. Okay. Okay, you can do the same thing. Okay, picking manual, something like that. For carbons, it's 77. So you can do it like manual. It's not correct. Okay, this one I can do it. Calibrate axis. Calibrate, no. Axis. Oh, it's 77 value. It's already corrected. Okay. But the peak is not correct. Okay, and peak okay. and the reading is there. We don't use too much the value for integral here, okay? And I'm not sure what is the purpose of this integral value. I'm not sure. So and if for example this is for example I just make a scenes. So oh, this is my compound peak. So why it's not? You can do it manually. Go to peak. Okay, define. Let's put here. This is my new compound, new peak. This is my new peak. Okay, but actually this is not the peak. Okay, so if you're very confident with the peaks, and you can save it. Okay, but I don't want to save because this is my master. Okay, so okay, the adjust phase. This is the adjust phase. If the baseline is not okay, you can playing around. Okay, can do it like this. Okay, or you can do like this. For example, I don't want to be like this. The positive mode is not. It's typical. It's not new. I want to process the data with the negative mode. So go ahead. Okay, you can do like this. But you will headache. Okay. So it's better to put like this. Okay. Okay. So if you see for example like this region is not really smooth, you can adjust. Okay, until you're satisfied. Okay, I don't want. You see in here, it's bend down. Okay, you can until you're satisfied the baseline. Okay, voila. Okay, this is the good one. Okay, this is for carbon. Okay, I'll leave it here. I'll leave it here because we will call that. So I open that 135. Okay. That 135, okay, on the positive, we have two phase here. For the positive phase, usually measure CH, CH3. Okay, no quaternary. So you have already have informations. The signal which is exists in carbon, not exists in that 135, it's C quaternary. I hope you understand what is carbon quaternary. It's already the carbon is already substituted with the groups. Okay, so there are no protons. Okay, so this is the purpose of 135. The negative. This is the negative. This is the negative. The negative is CH2. Okay, and the positive CH3. Okay. For example, it's happened when you have triterpene compounds. Now, normally it's mixed up. Okay, you said, this is terrible. So I don't accept it. Why did CH and CH3 measure in negative mode, not the positive mode? It's okay. Go to the adjust phase. Just change. Done. Okay, and you can change back. Okay. Okay. This is the depth 135. Okay. Depth 90. Okay. Depth 90 CH only. Okay, there are no negative, no positive, only CH. Okay, it's a very helpful information if you have it. Okay, you can do the same thing, adjust phase, picking, something like that. Okay, and next we will go to depth 45. Just drag. Okay. You will have CH3, CH3, CH2. Okay. Again. So, okay, next, how we can overlay all depth and carbon depth spectra in one page. Okay, so you're going here, multiple display. Okay, so you can go to last 50. You can drag all the spectra. Okay, for example, like this, drag. Okay. Drag. Okay, and lastly, you can drag this one. Okay, because this is already clicked. Okay, so I don't want to just want to okay, because this one is same spectra, you can delete. Click here, delete. Okay, so I want to increase this one only. Click here. Okay, unclick. I want to increase this one only. Okay, click here. Okay. So you have all information here. Okay, let us read together. So, okay, this compound in general, compound with code blah 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 contain how many quaternary? There is 1, 2, 3, 4. 4 quaternary. Okay, so you take a piece of paper like that and see quaternary for carbon. Okay, write down. So how many CH2? You have to go one by one until you satisfy. How many CH2? Okay, we have 2 CH2. Why? Because they have a negative mode in carbon 135 in the red regions. You see the red is carbon 135, depth 135. They have 3. Okay, take a piece of paper, CH2, 3. So you already have 4 plus 3 is 7. So check again, which one is the CH carbon? So CH carbon, this one, okay, that 19. So expand this one. You can expand, eh? You can expand. Don't worry. Okay, but make sure all the peak is overlay, same, yeah? Like this. It's easy for you to make a differentiation. Okay. So for example, this one, okay, this one is depth 90. So you want to know how many CH. And this is an example for what I can say recently I try to solve Soleh compounds and also Amirah yesterday. They will help you a lot if you have CH because you have CH2, CH, CH3 is less number, but CH you have a huge number of CH. And you have to differentiate between CH3, what is CH3, where is CH2. So for that 19, you have how many CH2? 1, 2, 3, 4, 5. CH, 1, 2, 3, 4, 5, 6, 7, 6. Let's see. So CH, let's see. 7, 9, 10, 11, 12. CH 12, for example, by using this kind of informations. Okay. So again, okay, this is very informative informations if you have and you manage to do it. So, but aware, you have to understand that because my previous sample, this sample contain ethyl acetates, there is some trace amount of carbon ethyl acetate exists in this particular compound. That's why if you want to run for the full spec carbon, I call full spec. For example, Soleh full spec. Amirah full spec. You know what the experiment full spec. This is proton carbon depth, COSY, HSQC, HMBC. It's all information. With that information, you have to make sure no impurities. Impurities is also no impurities, and also no solvent peaks. Okay, it's better. If you see impurities, purify. You are open to discuss with me what to do next, for example, like that. Okay. Okay, this is we already reached until that 135. Okay, until that, any questions? Close this one, okay? Any questions? I cannot see my chat box. There's a problem now.
Doctor, I have one question.
Okay, siapa tu?
Actually, I already wrote in the chat box.
Wrote what?
I write the question in the chat box.
Chat box, okay. Where is chat box? Chat box saya tak nampak kat mana chat box saya ni.
Okay, it's okay. I'll read it. Is it possible if say H16, let's say proton 16 is detected in proton NMR, but suddenly when we go to carbon NMR, there is no signal for carbon 16. Is it possible? Or is that mean our proton is not valid?
I think there is impurities. Most of the compound probably the impurities, but I have to see case by case. Otherwise, probably that compound is not exist in it's not exist in carbon, right?
Yeah.
Okay. There is another way. You can observe maybe the time of measurement for carbon is not enough. You can see in HMBC if they are quaternary, and you can see in HSQC if they are quaternary. You can see the contour.
But doctor, if we want to use HMBC or HSQC, it need 13 carbon 13 and proton, right?
You can use yes, yes.
Yeah, but there's no signal in my carbon 13.
You
So
can see the contour.
oh,
Like yesterday, I tried to solve NMR. Amira NMR. We cannot see the C acid peak. C double bond OH carboxylic acid, but we can see the contour in COOH. So we just read that NMR. Just take the value of carbon there.
oh, okay. Okay.
Okay. I will pick that question and I will show in my NMR. Okay. For the HMBC and HSQC discussion. So I want to ask any question for one HNMR first.
Another question, doctor. Can we detect a pseudo triplet using NMR proton
Pseudo
NMR?
triplet tu apa? Oh, ni chat dari
Pseudo
sini.
triplet is actually a quadruplet, but it has the same coupling constant.
I cannot imagine unless I can see the NMR. So, is it okay we discuss when you coming back?
Yeah.
Okay, it is happy to discuss case by case. Like Amira case, it's very interesting because last night I'm sleep early because I'm tired. Okay, so again, any questions? Okay, to make you familiar with this kind of broker software, Topspin, make sure you have your own NMR spectra and train. Okay, because like Shahira work, okay, sometimes I know that you are synthesize the simple compound in the beginning, but when you start to do coupling chlorine with the amine groups, you need HMBC because you need which chlorine they will coupling because you have the different substitution in benzene ring in quinazoline, Shira and also Laxani. You have to take note about this one. Whether they have when we do, I think you understand when we do chlorinations with POCl3, they will have possibility to have and proceed with the chlorination amination reactions. So they have two possibility, 50-50 the percents they will coupling whether in chlorine number 1 or chlorine number 2. So to determine which one is favor in this kind of reactions, you have to do HMBC to detect which chlorine they will coupling. I hope you understand, Shira, and also Laksani. Okay, about this one. Okay, for the anybody who are doing synthesis, sometimes you need 2D, sometimes you don't need 2D. But for 2D, usually we use to confirm 100% the position of the coupling. Okay. Any question from everybody before we proceed to 2D experiments? Okay, no. Okay, fine. Thank you, Soleh and also Huda who asked the questions. So let's go to the next one. We are focusing on COSY. Okay. This is very beautiful COSY, you see. So I learned a lot when I try to, because I self-learn about this software and something like that. Because the first installation in UM, when they try to transform from Geo to Brooker, now I'm involved unofficially and helping the design officer to install and learn, go for the workshop with them and find the books, because I'm still keeping the books how to run the NMR so on. So for example, this is the COSY. You can see, if you want to know what is COSY, you can see clearly the symmetrical line here. See, if you take the ruler, you can make one straight line here. It's kind of mirror image. It means this proton will never, okay, for example, I expand. You can expand this one. Okay, we don't, okay, we know this peak, and this peak is solvent peak, so we don't want it. Okay, so you can choose until this line, go here. Okay, and okay, the box is quite small, so I want to remove it. Okay, so put back the box and it's better. Okay, so you can see, for example, this proton is neighboring with this proton. You can see the mirror image for this one. Okay, and you can see here this proton is neighboring with these two proton. Okay, and this proton is neighboring with this proton. It's very clear about this one. So from here you can see this value here. You can see the cursor value. So for example, this proton is this value 6.732. You can see here. Okay, 6.732 with a neighboring proton 6.603, for example. Okay, nothing much we can do with the COSY to process. So just like that, and after that we print and do it manually. It's better to have a printed versions of NMR. I'm still doing and solving till now. Okay. Till now, I'm still print and try to do it and solve the structures. Okay. It's good to explore, train yourself, make yourself familiar with the peak. Oh, I know this peak is benzene ring peak. Oh, I know this one. This peak is alkene. I know this region is the unsaturated unsaturated regions. It's quite rare to have quaternary here, for example. Okay, this is the COSY. Okay, nothing much we can do. Okay. So we have HSQC. Oh yeah, for the COSY, okay, for the COSY, if you get the not really nice NMR, you can open, you can put the other NMR, which is represent your compound. For example, click your NMR. This is the 1H NMR file. Right click, display as 2D projections. They will ask display as F1 or F2 projections. So this one, this region is F2. Okay, see here, F2 is here, F1 is here. Okay, they have you have to project both of F1 and F2 is proton. So click here. Okay, they will change, but this is the real spectra, so they will not change. So here you can adjust, click here, okay. Click here, you can adjust the intensity, unclick, click here, adjust the intensity. What's happened if you click here and suddenly you click here, they will increase the intensity for the bow. What here? Okay, this one. And this one, this is, for example, this is too messy. You want to see a very specific file, you have to find the tune for the contour. This is what we call contour. Okay, contour. If you're learning geography and you see the mountain from the top, you can see the contour. Okay. So this is a 1D representation. This is a 2D contour representation, but I don't know how to read it. Okay. 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 Going back to here, and you will see. Okay. So again. Okay. You can adjust the contour. Okay. By scrolling up and down the mouse. Okay. So if they are too messy, for example, like this, oh, it's too messy. I just want to, okay, fine. Tune. This is fine. Okay, this is too messy. I don't see the, okay, this is too messy. This is, I cannot see anything, for example, like this. So, okay, do it slowly adjust. Okay, this is very important. Okay. How to know it? You have to try. Like Tahir, you have your own NMR. Who is that? The new students, Tahir. Idris is here. I don't see Idris. Idris, okay. Idris will have a proton NMR. I will give you after this. Don't worry. Okay. So this is kind of thing that you can do. Okay. So for example, if you click here and scroll 3. Okay, so don't do that. Okay, cozy is finished. Okay, anybody have question can put inside the chat box. I find it chat box. Where is it? Okay, next we have to go HSQC. Again, HSQC is similar like cozy, but the difference is the interface here. Okay, so this F2 is the proton and F1 is carbon. Okay, so if proton and carbon, you have to make sure it's aligned. Okay, the difference between HSQC and HMBC, HSQC will see their own carbon. So quaternary doesn't have any carbon. So that's why it doesn't have any information after 140 ppm. Okay, so again, you can adjust the proton, for example. We have proton here called C. Proton here, F2, click here, F2. F1, go to the carbon, display as 2 projections. F1, here, this is F1. Okay, so you can go, because this one is all about setting, that's why I don't want to miss any peak. Okay, for example, we know this is a solvent peak, so we try to don't take this one. Okay, the carbon start from here. Okay. For example, this peak is here. Okay, carbon. Okay, the value of carbon is 100. You can see here value. Okay, the carbon value of carbon is 121.8. The value of proton is 6.60 ppm. Okay, for example, like this. This one is 101.1 ppm, and the proton is 5.92. Okay, carbon 1 decimal, proton 2 decimal. Okay, 101.1, proton 5.92 ppm. Okay, so ignore this one. Okay, because there is solvent. Sometimes the solvent exists, the peak solvent of AZ. If you see clearly here, there is small peak here. Sometimes it's not very intense, so you can ignore that one. Okay. Okay, you can adjust the intensity or define the level. Okay. You see, when you try to increase the intensity, you can see the peak. And suddenly you ask, why peak this one exists in proton, but it's not exists in carbon, for example. So you can see here. Probably it's solvent or impurities. That's why if for the natural product chemistry, if you find these kind of situations, you have to carefully read which one is represent your compound, which one is represent the solvent, which one is represent the impurities. Okay. I forget the pass program for our experiment for HSQC. There is another pass program. You can differentiate the CH2 and the CH on CH by using color contour. I guess a Solihin NMR. No, Shifa. Let me check. Solihin can apply this one, but I'm not sure the past program. I have to check again the past program because it almost 5 years. I don't. Let me check the. Okay, let me check. 17, this one, I guess. Okay. This is the, I guess, HSQC or HSQC. If you get this kind of spectrum, don't panic. Okay. Playing around with the intensity, so scroll down, scroll down, scroll down, scroll down, scroll down, scroll down, and you will see the different color. Okay, again, expand because this is HSQC. The rest will be quaternary, so expand. Okay, you can see the different in color. You can see the different in color. The green one is the CH2. The blue one is CH3. This is a new. This is during 2012. This is new past program in Broker that differentiate CH and CH2. They will help you a lot. You can easily assign which one is CH, which one is CH2 by using this one. Oh, this is CH, makes sense because this one carbon have 2 protons, so they have CH2. And this one, oh, this has 1 proton, 1 carbon, but the integrations of the that particular proton is 2, for example, like that. Okay. And this one, for example, this is the CH2. They have different positions of proton A and proton B, for example, like that. Okay, so again, for examples, if the reading for the carbon is not correct, you have to correct it. Okay, by using this calibrate axis. So for example, this is shifted here. Okay, you have to go expand here, get the get the correct peak here. For example, write it. You have to calibrate, make sure everything is in order. Okay, so you have to calculate and check this value. So this peak is 5 This proton peak is 5.92 ppm for F2. Okay, and this carbon is 100.7 ppm for F1. Okay, so go to the center of this one. Okay, make sure center of this one. Go to calibrate axis. Go to center of this one. And put the value. Okay, 5.92. Okay, and this one 107, for example, and click OK, and they will adjust everything. Okay, and when you get this one, you can see okay, fine, this is very nice. You can see, oh yeah, correct, yeah, okay, fine. And this one, for example, okay, this one and this one. Okay, wait, try to do it. Okay, practice make perfect. Okay, next for the HMBC. HMBC, we'll minimize this one. Go to browser. I don't explain about noisy. Maybe in special case, I will explain in person to students. Okay, HMBC. If you see clearly, you can see the quaternary carbon. Okay. Okay. For example, okay. First, what you have to do, first you have to locate the proton and the carbon. Okay. So this one is carbon, F2 is carbon, F1 is the proton. Similar like HSQC. So first you have to expand. For example, Huda case, she said H16 is detected in proton NMR, but not detected in carbon. So this is the purpose of HSQC, HMBC. So even though, for example, we don't see this peak, I cannot hide this peak. Okay, if you don't see this peak, for example, you can still see the contour. Okay, so you can play around with the intensity of contour. Oh, you know, oh, okay, this contour. Okay, for example, you know this region. I guess this region is carboxylic acid. Okay, COOH, but it almost impossible. Okay, this one they have J2 or J3 coupling with these two protons, so you can calculate easily the locations. You can locate easily the location of these carbons, for examples. Okay, but to discuss in detail, we have to go case by case. Okay, another example. This is a good NMR for to detect the non-compound. Okay, for example, we know this peak is represent is in ethyl acetate. So we have this one peak and this one peak. If you see clearly, we cannot see any carbon here. Okay, it means this is carbon for ethyl acetate. So this is good example for learning only. This is not a good example for the thesis. Okay, so we can see example here, very nice spectral contour. So you can play around. Okay, if the contour like this, and for example like this and like this, you can take from here. Okay. You have to play around, otherwise it will become like this. I guess like this. You want to expand more contour, right? So if you see like this, okay, it's mean this carbon is confined. This proton can see this both carbon. Okay, this is how you read the NMR. We will see time to time about reading the NMR. So it later lah. So for processing is take a time to understand. Make sure you are familiar with the processing tools first. Okay. I think that's all for the HMBC. We already covered proton, carbon, depth, all three depths, COSY, HMBC, and HSQC. Again, for the HMBC, if you think the reading is not correct, so you have to do calibration axis, like I show in HSQC. Okay. So again, and again, if you see, okay, for example, this one, okay, this one. If you see, where is it, doctor? Because I don't see any peak here. Okay, if you see these kind of situations, it's mean they are in between. It's mean this peak is belong to yourself. Okay, this peak is belong to themselves. So it's not calculate during for calculations to measure the NMR, to measure the correlation. It's not calculated because this carbon is from the sun. Okay. So, any questions to ask? So, next, okay, you will work thoroughly on NMR. Make sure you understand the basic for NMR. It's very important to understand the basic of NMR before we go to complicated structures. So anybody who are doing nature products, that's why I asked you in the beginning doing literature reviews, because at least we have an idea what is the compound exists in that particular compound. For example, like Amira, they have a tricyclic, tetracyclic anodic acids and kingenins. For the Tahir, you have the Copsia and what types of indole they have. Even though Huda and also Tahir working on the similar indole compounds, but they have a different main skeletons. This is why I realized. Because Huda is a ebonine skeletons, but Tahir is a very complicated skeletons and very sensitive, I guess. Okay, for the Solihin, that's why I asked Solihin to do literature reviews, because if you have the idea what is the typical compound isolate, what is the skeleton itself, for example, linoleic acids, butylene types, ursine types, and also lupine types compounds. So for the Nurin, for Ain, Shira, Exels, Hadi, they have a, and also like Sunny, and also Sarah, you have a typical peak with what is will exist when you do reactions, what is will disappears. Okay, for example, like that. Okay, for Sarah, when you do condensation reactions, and after that, the aldehyde compound peak will disappear, should be disappear. If not, if still there, it's mean your reaction is not complete or not working, for example, like that. Okay? So it's very important, okay? Because this kind of understanding of NMR is very important for everybody. It's kind of needs to make sure all you call organic chemists know about this one, okay? Even in industry also, they will give you data, okay, please read it and interpret it. Okay. Another one is, okay,